This is example 10. For this example, so we're given this consolidation test data. So that's basically the stress and the corresponding void ratio. And also we're given time for 50% degree consolidation, 2.6. And then we're going to calculate that small k, hydraulic conductivity, that's small k here. So this is, again, the type 3, so that's third type of problem. For this example, to calculate permeability, so example 10. So to calculate this coefficient or coefficient permeability or hydraulic conductivity K, is C sub V, MV, gamma water. Okay. So that's the equation we're going to use. So it relates to the coefficient of consolidation in NV and gamma water. And for this example, we start from NV. Just as the previous one, this coefficient of volume compressibility is defined as A sub V over 1 plus E. In A sub V, again, that's basically delta E over delta sigma prime. Okay. So we have the consolidation test data. We have these two stress values and two corresponding void ratio. So we can calculate this ratio, ratio here, 1 plus E. So just as a previous example, so we have delta E is E naught minus E, or in this case, let's use 1 and 2 here, E1 minus E2. So that's 0.92 minus 0.78, 0.14. So that's a void ratio change. And then the corresponding effective stress change, we call delta sigma prime, sigma 2 prime minus sigma 1 prime. Again, the reason I'm using 2 minus 1 is to make sure we get a positive AV number. Okay. So that's 120 minus 50. Okay. So E2 is 120, E1 is 50, so that's 70. Unit is kilonewton per meter square. And then that E, again, we're going to use the averaged void ratio. So 1 over 2 E1 plus E2, 0.85. So substituting these values into this MV equation, so we have 0.14 over 70 over 1 plus 0.85. That's E average. And you get volume, coefficient of volume compressibility of 1.08 times 10 to negative 3 meter square per kilonewton. Right. So we have this MV. And unit weight of water constant, we don't need to worry about that. And then for C sub V, so C sub V, we are given time for 50% consolidation is 2.6 or 2.5 minutes. We're going to use that information to get C sub V. Okay. So first, for U of 50%, okay. Again, from Terzaghi's solution, same table. So table 11.7, we have the T sub V. So let me go to that table. So this time 50%. So this U of 50% corresponds to T sub V of 0.197. So this TV is 0.197. So let me write this number down here. So TV. So we have this time factor, and then to get coefficient of consolidation, this is TV HDR square over small t. Right. So in this expression, we know that time factor is 0.197. So we know this, corresponding to U of 50%. And then we need T and HDR. So this small t here. So this is the time to reach that 50% degree consolidation. For this example, this is basically small t. Okay. So we know the time is 2.5 minutes. Okay. So that's small t. And really the only thing left is this HDR. So that's the maximum drainage distance. And for this example, so pay attention to the problem statement here. So this is a lab consolidation test. So you all did this in the lab, you put porous stones on top and at the bottom. So it's a double drained system. So it's two-way drainage. So this is draining on both sides. Okay. So it's a two-way drainage, which means your HDR is half of the thickness of the specimen. Okay. So that's the maximum drainage distance corresponding to two-way drainage case. It's half of the thickness of the specimen. Okay. And this is in millimeter. Okay. All right. So with this information, so now we have 0.197. That's TV. And HDR, we said that that's half of the specimen thickness. So that's 1/2 of 25. And we're going to convert millimeter to meter. So that's so this is millimeter to meter conversion. And divide that by time t 2.5. The unit for that is minute. Okay. And the coefficient of consolidation, therefore, is 1.23 times 10 to negative 5. Meter square per minute. Right. So now we have this C sub V taken care of. And gamma W, unit weight of water, again, 9.81 in SI unit. So we have this K. So we can calculate the hydraulic conductivity, C sub V, and V, gamma water. Okay. So 1.23 times 10 to negative 5. That's meter square per minute unit times NV 1.08 times 10 to negative 3. That's MV. Meter square per kilonewton times then 9.81. So that's kilonewton per meter cube. So that's unit weight of water. And this gives us 1.303, 10 to negative 7 meter per minute. So that's the hydraulic conductivity of that clay specimen.